Testies. Unpause. So this is starting now, so we are going into the voice channel. Waiting on the masterclass presentation.
clicking test video, we see exactly what OBS is outputting. Currently, it's just the OBS icon. Icon and a no camera button, meaning that it's not outputting. If we head across to OBS and click Start Virtual Camera, you'll see that whatever our active scene is then showed as a virtual camera over here. Now, of course, you can add literally anything to this: images, a physical webcam, an NDI stream, etc., etc., and you'll be able to use it as a webcam in Discord, Skype, Zoom, Teams, etc., etc. All of that with the simple click of a button now that it's built into OBS. Whatever your screen size is and FPS, inside of the settings video section over here will be the settings for your virtual camera. Super simple, and it works just about anywhere. Now, before you had to download and use a plugin. Because this new process is so simple, this video would be about 10 seconds. What was the old process and how do we go ahead and do it? Well, say that you like using an older version of OBS for some reason, such as this one over here. How do we install the plugin? Well, simply head across to the link in the description down below and you'll be taken to OBS Virtual Cam 2.0.5. When you get to this page, you'll scroll down and you'll find some info on how to actually use this plugin. All we have to do is simply scroll up to the top and click Go to Download. This will take us across to a direct download link from the official GitHub page for this project. All we have to do is simply close out of OBS and open up this exe. I'll click Next, Next, and then we get to pick where the program is actually installed. Now for me, because I won't be installing this to the official OBS, I'll be using one and
Did you know that Discord is releasing
Okay, hello. I've set up this new stage channel in Discord. I thought, yeah, since there's a fair few people here, might as well start now. Stage channel in Discord. And so what I've actually noticed, first thing off, is that they don't actually let you share screens in this stage channel area. So I think what I'm going to have to ask everyone to do is to move over to the general channel. If anyone wants to do that now, and I'll see if people are doing that, and if not, I'll figure out how to actually move you all over. Cool, looks like people are moving over, so cheers. Awesome. So, thanks for jumping in this side of it. Might have to just, rely on people to keep themselves muted and all that. And I'll figure out that stage setting another time. So, since there's a fair few people in already, I think it'd be cool to just start off now. The idea with these Wednesday visits is that we kind of just want to get together, probably same time on a Wednesday, get together and just shoot some ideas around. We had a good one yesterday, last week, and we just decided that it'd be cool to like dive right into it and do a bit of a run through. And Sem has very kindly said that he would do a run through on Niagara, so I guess that's why a lot of you are here. You've been like, oh, Niagara, awesome. But the idea with the Wednesdays is that we sort of get together and just share notes, share things that we've learned. So maybe a really cool thing to do after this first week, after we've had some cool tips from Sem, would be to maybe come back next Wednesday, share things that we might have learned, and share some cool things that we've made after learning this stuff. And hopefully things can sort of roll like that. I think we'll try and do a nice big talk, maybe once a month or once every 3 weeks or something. So that'll always be promoted out, so watch out for those. But after each sort of presentation, we'll have a couple weeks of kind of cool off period where we can just share some notes and share some ideas around what we might have learned in the previous sessions. So you're all here to learn some stuff about Niagara, and we've got the lovely Sem Schreuder in.
Hello.
Here he is.
Here I am.
Me and you have had a couple chats before, haven't we, about some of the awesome work you've been doing, but yeah, basically Sem being a mad creative coder, sort of VJ, visual programmer. Did you want to
Doing
just...
cool stuff with pixels.
Yeah, exactly. And so the idea here with your talk today is to go over some Niagara stuff, but then also go into changing Niagara things in blueprints as well. Is that right?
Yeah, so getting more interactivity with your Niagara system. So basically, a lot of Niagara systems tend to be kind of static, and I want to show a way of, basically, interact, have actors interact with your Niagara system.
Awesome. Sounds awesome. Are you happy to jump in and just share your screen then?
Yeah, sure. Let's check it out. This is the first time I'm sharing my screen through Discord, so...
No worries. Maybe if I just mention while we're figuring that out, if anyone wants to add any comments or questions, if you want to like chuck it in the voice chat notes, which is still under the voice channel section in the Discord on the left there, you can add any thoughts or questions in there if you like. This is also streaming out on YouTube now, so if that's easier for anyone to watch, I'll just chuck the link in that now for people to watch.
So I am sharing my screen, and if anyone can tell me if they can actually read what's on my screen, that would be helpful.
Yeah, for me it's looking pretty good quality.
Really? Okay, cool.
Mm.
So yeah, I can basically dive into it. I have prepared a little bit of something. 1 second. So basically, what I've been asked to do is before in earlier projects is to basically create an interactive particle system, and so I wanted to kind of showcase some of these projects. So this was for a TV show. There was this band performance, and we basically put the lead singer behind this kind of mesh screen, and we project visuals onto the mesh screen, so you can still see the see the singer, but also see the visuals in front of him. And basically, what I did was I installed a Kinect, and I made a blueprint that sends the Kinect data over to Niagara, and Niagara does cool stuff with the movements. So here you can see the I was lucky that the singer was moving around a lot, because that really helps. If someone's standing still, then there is no interactivity. But yeah, so that's one example. Other one is a demo I've made earlier. This was the first time that I started working with basically interactivity. This is also with the Kinect, and I found out a way to move particles around just by hitting them. So yeah, you can already kind of imagine what happens if this image was to be projected onto the same wall. Then I could basically just hit particles and kind of interact with the particles while they are being projected onto the same wall. So I wanted to kind of show everyone how to set up the pipeline for this. It's not that hard, but yeah, let me just show you what I do. I
Yeah, I love
hope it
that
doesn't
sense
have
of
to compile.
yeah.
Hmm?
You've also almost got like a virtual production sense of back and forth there with the you being in the physical space, interacting with the particles, and then if you laid those back over, got some real simulation sense there, which is nice.
Yeah. Whoops. That's one of the fun parts about rendering in real time, is that you get to interact with your visuals, right? So that's mainly one of the first things that I want to do is just find a way to either connect it to audio, or connect it to my hands, or connect it to anything. And that's what I've been doing basically, how to connect everything to everything.
Yeah, makes it really
Um,
fun. Yeah.
yeah, that's at least that's the fun part for me. So I set up this quick scene with this cube that consists of thousands of other cubes. And if I press simulate, I have an actor here, just a sphere. And if I drag it around, I hope that everyone can see this clearly. If I drag it around, then this sphere is interacting with my particle system, right? So the outside world is actually interacting with with the system. And right now it's a sphere, but in the other examples, there was no sphere, because I only needed the vector locations of the Kinect. But this could be anything. You could animate this to audio, or you could basically grab anything from Unreal and send it over or use the data in Niagara. So basically what I wanted to do is recreate everything from scratch. So let me just delete this and keep the world stuff. And yeah, let's make a new folder. Call it I don't know. This is always like the hardest part for me is to come up with names for all these assets. Let's see. So I don't know, tutorial live. It helps. I actually I do that as well. Like I use kind of a naming convention that I saw other people use. That's basically beginning with either BP or Niagara system NS, but then I do underscore SH, and the SH is basically to mark it as my own. That helps for when I'm searching for stuff. So if I'm looking for stuff, especially when you're working with like 20 other creators inside one Unreal project, then you have like hundreds and hundreds of assets, and then the search bar becomes really handy. So that's also why I use these initials, just in case anyone was wondering about that. So yeah, basically what I do is whenever I start to create a new system or particle system, is I create a blueprint and a Niagara system, and I shove the Niagara system into the blueprint right away. So let me first create a blueprint, BP underscore sh, I don't know, lots of cubes, and I drag it into the level. Basically set it at 0, 0, 0. And I create a Niagara system. It doesn't really matter which template you use. I always start with this template. That's just a workflow thingy I've implemented myself, but you can grab any of these. But I mainly pick out hanging particulates. It's just an easy starting point. Hit finish. And this is going to be lots of cubes. All right, in the blueprint editor, actually, I normally work on 2 screens, so I have to improvise how to work on 1 screen. But yeah, let's add the Niagara system into our blueprint. And then we should see some particles in our level editor and in our blueprint editor. Cool. So first, let's actually render some cubes instead of sprites. Well, first thing, because I have a beefy GPU instead of a heavy CPU, I'm going to set it to a GPU compute sim. Let's also hit fixed bounds, and I'm going to set the fixed bounds to minus 10,000. 10,000 minus 10,000. This is so that your GPU knows what the bounds are of the particle system. If the particles actually go outside of these bounds, then the whole system will start to glitch. So in order to prevent some flickering, you can set these values, the bounds values, to minus 10,000 for min and max 10,000 as well. Yeah. Yeah, so you fix it by increasing the bounds like this. But I think that you will also use more video memory just by increasing these bounds. It makes sense. I could be talking out of my ass, but I don't know. So at least you'll prevent some flickering and some glitching by doing this. So instead of sprites, I want to render meshes. So let's add a mesh renderer. Where, right, I need to set a mesh. Cube, so many cubes. Cool. And now let's actually change the initial scale as well. So just go to initialize particle, set the mesh scale attribute to unset, or set the mesh scale mode to uniform. Otherwise, your meshes will just disappear if you try to scale them down later on, which is kind of silly. But let's leave it at 1. And then in the particle update stage, this runs on every frame for every particle. We can just add a mesh scale size module. And then instead of scaling it with a vector, we can scale it with a float. So we can go from vector to float. And now we have one float with which we can, control the size of these cubes. So if I set it to 0.1, they are smaller and better. And now if I increase the spawn rate by a lot, let's say 7,000 for now, then it kind of looks like a blob of cubes, right? Right. So in the blueprint, I want the Niagara system to actually cast some shadows as well. So I can go into the details tab and hit cast shadows. Now it looks even better because they cast shadows. They interact with the lighting system in Unreal. So at this stage, what you can do if you want to have the particles basically, so if you want to scale the particle systems, let's say I want the particles to also spawn just at the end, at the bounds of this floor, then you could grab the blueprint, scale it up. You can, in the blueprint, you could kind of scale the Niagara system, but that's not really the neat way of doing it. The neat way of doing it is by changing these locations. So basically the template comes with a box location and a sphere location. Now we don't really need that sphere location. We just want the box location. And it just kind of spawns sprites or particles into a box. Now, this box has initial values of 400 by 400 by 100, and I'm going to change it to 100 by 100. Now, in the blueprint, what I do a lot of the times is I add a cube or now a box collision, right? Yeah, a box collision. A box collision. Right. Yeah. There is a box collision, but it's hidden hidden in the cubes. And in the box collision, I can change the stand to kind of match the system. I tend to eyeball this. So let's set it at 70, 70, 70, 70. Yeah, 70, 70, 70 should be good. Right, so now we can kind of visualize the bounding box of the particle system. Let's actually set it to 50 by 50 by 50. Yeah, 60. Yeah, that's better, right? And what I like to do is in the construction script, grab the box and set scale, set world scale 3D, and then make this a variable. So we can say system bounds and make it visible. Now, what I want to do in the level editor is basically Right, so it is set to 0 initially. So let's change it to 1 by 1 by 1. So in the level editor, what I want to do, I don't know if you can see this in stream, but there is a bounding box here. Let me just increase the line thickness. Yeah, thick lines. And it would be very handy to just change the box and have the particles, yeah, interact with the box basically. So what we can do is we can create a user parameter. Let's make a vector and let's call this bounds, right? And we're going to set this bounds from the blueprint. And this bounds user parameter is going to be attached to the box size. So let's set this vector to our box size. And then in the blueprint, we can grab our Niagara system and just say set vector parameter like that. And then we can grab our system bounds again. This system bounds needs to be multiplied by 100. So we can multiply it with a float to get it within the same range as as Niagara. And all we need to do now is copy the bounds, copy the reference, and paste it into here, into the parameter name. So right now, in the level editor, I could basically just change the system bounds on the fly and have the particles, yeah. So now the particles spawn right inside of the system bounds, which makes world building just a little bit easier because you know exactly how big your system is and what its bounds are. And this is the first example of how to interact with your particle system coming from blueprints, right?
Yeah, awesome. Super useful. Definitely that real-time element, real-time editing is amazing.
Yeah, I tend not to work in the construction script a lot because if you do, you could mess up the actual level editor. But and then you have to revert back into a point where you didn't fuck it up for other people. But yeah, no, the construction script is really handy for this kind of stuff. Just basically have code run inside the editor without having to press play. You get to immediately see some changes. And this is one of those changes that's actually kind of handy to do in the construction script. So I can increase the size of this thing as well. Actually, let me get rid of the floor. Don't really need it anymore. And yeah, so let's actually add another actor, and let's use that actor to interact with our particle system. So let me just create a new blueprint, an actor, call it BP underscore sh, I don't know, interaction, dude. And I'm going to drag it in the level as well. By the way, if everyone can just kind of mute their mic, that would be helpful. Thank you.
Exhibit A there. Just trying to mute people as they come in as well.
Yeah, my ADHD tends to focus on everything all at once. So as soon as I hear something, I'm like completely distracted and I want to know what's going on. But that's just me. So right, so this blueprint, lots of cubes, needs to know some stuff from our new BP interaction dude, right? Um, and the way blueprints can communicate with each other is basically by referencing the other blueprints.
Which in general is just a really nice lesson just to open blueprints out for a lot of people.
Oh yeah, for sure. 1 second, I'm just gonna try and mute some people myself. Who's making the noise? Ah, Sex Electro. Right. Okay. I muted him. Okay, cool. So onwards. So this blueprint contains the particle system. This blueprint we want to use to interact with our particle system with. So this blueprint needs to know some stuff from this blueprint. Actually, in our interaction dude, let's open it up and let's add an actual static mesh. So let's add a sphere so we can see it better. Right. So let's reference this, interaction dude. The way I do it is also in the construction script, and I do it by finding actors. So get all actors of class.
ماني هذا يقول نو ماني يقول أن يعطيني ماني
Yeah, yeah, yeah.
I'll try and find a way that
I Yeah, no worries. I know how to mute people now, so I can be really quick about that. So what I do to reference this interaction dude is I get all actors of class. Then this gives me an array of all the possible actors that are in the level. But I know at this point I'm only using one, so let me just get the first one out of the array and let's store it into a variable. So this is a variable of our interaction dude reference. Here we go. And now that we have a reference set in the construction script in the event graph, I could basically on-tick get the actor location of our interaction dude. So I can drag out the pin and say get location, get actor location, right? Yeah. In Niagara, it would be nice to receive this vector. The way to do that is by creating another user variable. Let's call this one, well, let's make a user exposed variable. Let's make it a vector and let's call it dude location. And in our blueprint, we just drag out our system into the event graph, drag out the pin and say set vector parameter. Here we go. And I want to set the vector parameter in every frame. That's fine. And just connect it straight up like this. So right now the interaction dude reference is giving its location to our Niagara system. Oh, right. I forgot to fill in a parameter name. I always forget that step. And then it doesn't work. And then I'm like, why? Why didn't it work? Copy reference, paste it into the parameter name, user.dude location. And if we hit play. Yeah. But oh, that's a lot of errors. Right. So this error happens from time to time. That's basically help. I cannot find your reference. I don't know what you're talking about. I don't know what to set. So what we can do here is basically if this is valid, is it valid? Let's check it if it's valid, and if it's valid or not, let's also create a variable and set it. So legit, dude. No, is dude legit? Is dude le- legit? Normally, I'm better with naming variables, but not today, apparently. So in the event tick, right before we are going to set our vector parameter, we can basically ask, hey, is dude legit? And then we can say, well, if the dude is legit, then let's set some vector parameters just to get rid of that error. I don't know why. Yeah, that reference didn't work the other time. Let me just expose interaction dude reference. We can expose it, and interaction dude none. Well, that's weird. It doesn't want to set this variable. All right, the variable type is an actor instead of that exact. Right. It kind of right. Get all actors of class needs to have an actual class, otherwise it just gets cast as an actor, and an actor can be anything. So for the actor class, we actually have to say get class of interaction, dude. And then we get the first one out of the level, and then we can store this as, let me actually get rid of interaction dude right there. All right, then we can store this class into your variable. So interaction dude reference. This is also the fun bit about live coding is you get to see all the errors. Yeah. And that could be helpful as well. If you're watching a tutorial, then most of the time it's edited, and the person that's giving the tutorial, me included, edited out the parts where it didn't work, right? Because who wants to see that? But yeah, this could actually be helpful in a way. We can still say, we can still ask like, hey, this interaction dude reference is now of type BPSH interactive dude, which is the good type. And then we ask, is it valid? And then we set it to our own bool variable. Here we go. All right. Now we can actually get our interaction dude reference, get the actor location, and send that actor location towards Niagara. So let me compile and save. And yeah, so dude is legit. You can see it in the debug. Cool. All right. So now I know that this vector param is actually is being sent over. In Niagara, there are tons of ways where you can implement this vector. Basically, everywhere. Yeah, basically everywhere. That makes Niagara so incredibly convoluted, right? They pretty much said like, hey, here's everything, and you can do everything. But that also results in kind of a convoluted UI, and it's a bit overwhelming. At least it was overwhelming for me when I first started. Now I kind of know my way around, but yeah, it's still a lot. But that's also the fun part, right? So we have a vector here, dude location, and we can implement that vector anywhere. Right now, I have a bunch of stuff I don't really need. Like I have skill sprite size, I don't need that. Skill color, don't really need that. What I would like is maybe a point attraction force. So you can't really see anything. Maybe in the middle. Maybe if I set the strength to be higher. Where is my point detection voice? Oh, right. Yeah. Okay. So it is spewing some particles around. Also the attenuation. Yeah. So it is doing something, quite something, but it is dead center, and it doesn't look good. Right. Yeah. So the point attraction force attracts particles onto a vector, but it can also push vectors outwards. If you set the attraction strength to something into below zero, basically, so minus 500, then it pushes particles out. And let's actually set the attenuation radius to something a bit lower. So it only pushes out particles uh, uh, with a predetermined sphere-like bound, right? So we have a location vector coming from our blueprint on event begin play, and wait. So I really thought I just created a user vector, but apparently I didn't. So let's create it again. Vector, location, dude, location. Here we go. And now let's make sure in BP lots of cubes, this is still the right. Don't know why my user parameter just disappeared, but it's back. All right, so point attraction force has a bunch of parameters, but also an attractor position. And this attractor position is a vector. And maybe you've probably already guessed what I'm going to do, but I'm going to set this to our very own dude location. So if I hit save and if I start playing, then with a bit of luck, if I grab our dude and if I push it, yeah, you can already see some particles start to move away from our actor, like that. I can increase the strength, maybe not increase the strength, but increase the attenuation radius. And more muting. All right. So right now the cubes are yeah, they're skating away like they're on ice. Basically, they never really stop moving. Well, they do eventually, and that is you can actually control how much they are allowed to move after they've received velocity from a force. That sounds more complicated than it is, but you have a drag module, right? And with drag, you can determine the amount of drag a particle has, and the more drag, the more it wants to stand still, unless the force is really heavy. So right now it's set to random range from float. Don't really need that. We can just directly set the drag with one float, and I'm going to set it to 10. And you can see they are less skatey. They less want to float away from everything. But we can still interact with them in this cool way, just by kind of moving our actor around. Whoop, whoop. Ah, that looks great. Okay, so yeah, that's kind of what I wanted to show you. And yeah, I can maybe do some other cool stuff. Let's see. I can have the actor change the color based on the location as well. That's a fun one. So basically, I add a material to our cubes, and this is where my initial search function comes in handy. I can just search for everything matte sh, and it's not there. Let me just disable some content here. Matte sh cube matte. Now they're all extremely white. And let's set the color every frame for every particle. Cube. Huh. It looks like there's also some emission going on. So let me quickly, by the way, in your material, in your particle material, you can use the particle color thingy if you want Niagara to change the color. But I don't want it to change the emission. I just want it to set the base color. So if I hit save, they should be less emissive. Yeah, it looks slightly better. Lots of cubes. Let's actually set the color to something more dark, more better. All right. And we can lerp colors as well. So we can linear interpolate between two colors just by typing in lerp linear colors. And then we can go from, I don't know, blue to the opposite of blue, black. No, this yellow should be good. And then with this lerp factor, you could kind of it is actually the whole scene is kind of bright. So let me just kind of tone down. The skylight is also set to weird stuff going on. Yeah, that is a bit better. Let's actually build the lights as well. Maybe. Right. That changed something. Let's change back the skylight again, because I do want a bit of that. Let's go to specify cube map. Da-da-da-da-da. That's too much. And let's build lightning only. Like the refinement stage of a workshop or of a stream like this is never really the fun part, because making stuff look good takes a lot of tweaking, and tweaking isn't really that interesting to watch. That's why I always start my tutorials out with basically just a scene that already looks good, and then I start coding. But yeah, that's the yeah, for sure. And that's also quite the fun part is basically tweaking until it looks somewhat decent. All right. Think yeah, I'm just gonna leave the tweaking up to the pros. And show yeah, yeah, sure. Right. So there's a lerp factor here. And if I set the lerp factor to 0, then all the cubes are blue. And if I set the lerp factor to 1, then all my cubes are, well, actually they're kind of blue, but that's because of the skylight. They're supposed to be yellow. So let me quickly change that to a white kind of HDR. And Actually, let's change the material again because I do want to show off some colors, but right now the roughness is maybe a bit too high. And I did cast shadows, right? Yes, it is casting shadows. All right, well, weird.
We had a question in our YouTube about kind of like what you were demonstrating at the beginning, I guess, with Kinect. They said, is it possible to get interaction with mocap or live link data? So I guess that's sort of like, would you do that?
Ye-
Would you? So that's sort of like that single ball represents a similar thing to what you would do with Kinect or live link, isn't it?
Exactly. Yeah, for sure. So in with the Kinect, you get a lot more points, but they're all just factors, right? So you get an array of factors, and one of these factors could be an elbow, or one of these factors could be a head. So what I did was I tried to figure out which of the factors was the hands, and then it's the same thing. You just reference the hands, or you just reference that set vector value, and you get that vector value inside of your Blueprint Niagara container, and then you can use that vector value uh, 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 in your Niagara system, basically by hooking it up inside your blueprint. That's the pipeline. But yeah, it could be anything, and it's all just data anyway. Like a mocap, especially a mocap, is just a big array of vector locations, probably.
So it's almost exactly the same thing, but it's just instead of getting the location of that one actor, you get the location of the mocap points, isn't it?
Yeah, for sure. Like if right now for demonstration purposes, I've made just one sphere that, and I'm just sending this one vector location over. But actually, let me grab. Let's go to don't save. Yes. Right. Do I still have no? So let me kind of. Yeah. Okay. This interactive grid. Yeah, it looked good, huh? Whoa.
Lava sort of feel.
No, this was the same system that I made earlier without all the bugs. Let's increase the bounce scale. Set it to something like this. Let's make a cube of 50 by 50 by 50. Yeah, that's no, that's too big. 10 by 10 by 10. That's good. All right. And then I have an interaction sphere here. And if I hit simulate, then you can see that, yeah, they're being pushed away, just like I've made earlier, but they also change colors, right? And how I did that, let me just quickly show you, is you create a loop. Actually, I can do this bit again. So we create a loop. So linear interpolate between two colors. And we can set the first color to something blue, set the second color to something else. And then we have this one single float value that goes from 1 to 0, right? And we can use normalized distance range to change that value for each particle. So remember, the particle update is one giant for loop that runs every frame, but it also runs for every particle, if that makes sense. So we can actually say, what is your current position? We can ask the particle, hey, what is your current position? and how far away are you from another particle, or how far away are you from another vector? And that's what we're doing here. We can say start position a particle, the position of the particle. So you can ask the particle, hey, where are you right now? And then you can say, what is your distance from another given vector? And that other given vector could be our very own interaction sphere location. Yeah, the variables are named different this time. But interaction sphere location. Yeah, interaction sphere. Interaction sphere location. Right. Now nothing is happening. That's because it needs to know the distance. That didn't really work, huh? It's not, it doesn't need to be in local space. Huh. I wanted to show something cool, but it's not working. I broke it. Anyway, this is just to show you how you can, where you can use this one single vector, right?
It's
So,
nice to show that principle for sure of like, you got this color changing over time, then you got things that can affect that, and it's just kind of like have a play with what things could do there, isn't it?
yeah, for sure. Actually, once you get over the fact that Niagara is super convoluted, it is kind of a playground as well. Like you have so many variables to tweak, and it is breakable. Like you could still crash Unreal even with the 4.27 version just with Niagara alone. But yeah, you can pretty much push it pretty far, I think.
Yeah, and seems way more stable than a lot of other kind of particle systems. I find it not crashing
Mm.
even at all, which is really nice.
Actually, in Unreal, you mean? Because I've only used Niagara. I've never actually used the other
I thought saying
part of
compared
the
to like
system.
Blender or something.
Oh, right. Yeah. Now Blender actually fries my computer because everything is run on the CPU. So yeah, my computer is not fit for Blender particles. So yeah, that's actually one of the main things that I wanted to show. Are there any questions? Like, is anyone wondering something? Maybe I could answer them.
Yeah, it's a good shout. Either jump in voice chat notes. I'll check the YouTube as well. Sean Becker seems to have some questions. Is he on here? I'll say go ahead on the YouTube anyway. But
Hey, this is poor Marty. I got a question.
how you doing?
Oh man, thank you.
Hello.
How's it going? This was amazing. I I get take you to get comfortable in Niagara. I actually like I've been building in Unreal, but um Niagara feels like a far away place. But how long have you been building in Niagara, and how long did it take you to get comfortable to just pulling everything out like that?
Right. Now, good question. There wasn't a certain point in time where I thought like this is it. Now I know. Now I feel comfortable. I still sometimes I break it and then I'm like, what did I do? How do I get back to a place where it didn't look bad? And so I am still not entirely comfortable, but I have been working with Niagara professionally for about a year now. and within that year, I can build a bunch of stuff, and it depends on how long that will take. But fully comfortable, nah.
That's always it's always funny hearing people say that when you can't do half of. I'm just like, oh my goodness, like I can't even do that. Like, how'd you? But and to hear that you don't even feel that comfortable. Um, Another question, really quick, was how
Yeah,
did you?
sure.
What did you do to pull in the connect? Like, was it like how did you connect the connect?
How did you connect to Kinect? Good question. So basically, I've been using Kinect Azure. I have been using Kinect for 8 years, but in different software. But that was always the Kinect one or the 1414. That Kinect was horrible. The Kinect Azure is pretty good. I like it a lot. It does get glitchy when you're further away, and someone basically wrote a plugin to receive the Kinect Azure into Unreal. And let me just quickly look it up. So I think Kinect Azure UE4 GitHub. It is by secret location. Yeah. So this dude or person or whatever wrote this plugin, and it takes a little bit of effort to install it. It doesn't work straight away, and it doesn't work on the 30 generation 30X graphics card. So this plugin doesn't work on my current computer because I'm using a 3080 graphics card. So keep that in mind. But yeah, that's how I did it. And basically, this plugin gives you an actor with all the locations from every bone as a vector or as an animation blueprint as well. So you can drive like the mannequin with this plugin. It's once you've got it installed, it's pretty easy.
I have the V2 Connect, and I just started using Episoft. I guess the plugin. It's
Yeah,
yeah.
there's an Epic Market plugin for the Kinect 2, right?
Is there?
Yeah. So I didn't use that because I have a Kinect Azure instead of the V2. But if you go to Marketplace, there is a Kinect plugin that works with the Kinect 1 and the Kinect 2. I'm pretty sure. Yeah, here, Neo Kinect. I've heard some good things about this plugin. And
Okay.
you could basically mocap. And as you can see here, these are just vector locations, right? And you can reference these vector locations. Probably, I haven't worked with this exact plugin, but it's kind of the same workflow as I shown earlier. You reference another actor, you get a vector location, and you set that vector location inside Niagara.
Okay. Might have to hit up Episoft and get my money back. Thank you. Thank you. Thank you.
Yeah, no worries. Oop, I'm just gonna play with this.
Yeah, thanks. Yeah, I had a question on the YouTube.
Mhm.
So, been experimenting with making larger sandstorm particle systems that move across the map. Any advice of how I could approach doing that sort of effect from a performance standpoint? I guess getting a
Um,
big swarm of particles but keeping it performing nicely, maybe.
well, It, yeah, performance wise, I've only been working with Niagara ever since I've got this kind of beefy computer, right? So I always try to, well, the thing that kind of slows down your computer performance the most is the amount of particles. And so it's all pretty much determined in how many particles are currently rendered. And you can actually, I tried experimenting with this, you can add like 200 curl noise forces all stacked on top of each other, and that won't even impact the performance that much. So you can basically go crazy in the particle update stage. You can go crazy in the particle spawn stage. You can go pretty crazy in the material stage, for all I've noticed. And even with like right now, I am sending one vector, but Niagara also has, like right now I have a user variable of one vector, but Niagara also does arrays, so you can also say vector array, and you can fill this vector array of hundreds and hundreds of vectors and just send it over and use it anywhere else in your system. And that won't even slow it down one bit. But the one thing that really slows down your game or your production or whatever is the amount of particles. And the amount of particles is heavily dependent on your GPU, basically. So if you have a good GPU and if you set the system to GPU compute sim, then yeah, just kind of crank it up until the FPS starts to break. That's the only tip I have for you.
I was like rendering loads of copies of my head from my character, and I was like, wow, this isn't even impacting performance at all. And it's like that's quite a high poly model that's just being repeated loads of times.
Yeah, it's crazy. I always keep being surprised by the performance wise by how well it is running, basically, because this also just setting the vector parameter. I do this on tick, and they always say like be careful what you do on tick. That is true, definitely the case. Don't do that much stuff on tick, but setting Niagara parameters on tick, no problem.
Really interesting what you say about you could just stack up the actual forces as much as you want. I didn't really think about that. Could just be a
Yeah,
don't see why that would impact performance that much now that I think about it.
yeah. So this this whole thing kind of compiles. It does take forever to compile. So right now it is Niagara is set to automatically compile when graph changes. If you have 200 curl noise voices, you want to turn off this toggle, because every time you change it, it will compile, and it will compile for half an hour. So, but once it's compiled, it is super effective.
Yeah, really cool, really cool. Did anyone else have a question? Hey, Richard.
Hey, you all right, Rick? How's it going?
Again,
Yeah, good. Yeah, I've got a question for you, Sam. I saw a tutorial ages ago where they brought in a skeletal mesh into Niagara,
Mhm.
and I was just wondering if you'd ever done that, and if you could show us quickly how to do it, maybe.
Yeah, sure. So let me add a skeletal mesh first. I think I can just quickly wait. I need my space to be bigger, otherwise I cannot use the add feature or content pack. Let's add the third person duty. Here we go. Add to project. That's fine.
Yeah.
So in here, we hopefully have our mannequin character skeletal mesh, male or female. In Niagara, let's just create a new system, right? So I always start out the same with these hanging particulates. ns underscore mannequin. Yeah, I don't know how to spell mannequin.
Okay.
Dude. Yeah. Today I'm calling everything a dude.
Good. I think really good thing about these kind of streams is, or just in the way that you're explaining it, is you're explaining it in those kind of terms which are more understandable. Where it's like, oh, this is now actually asking this, you know, or this dude is actually doing this. Makes it a lot easier to process the information.
Yeah, it's the why and not just show you the how. That's always what I wonder as well. Like why why does it work like that, and why are people just implementing it like it's nothing? So in our new NSSH dude, I can basically change some stuff to have it run on the GPU as well. And let's increase the spawn rate as well. So the particle system basically wants to know where particles are spawned. And we have been using a box location for all this time, but we can also use the skeletal mesh for that, I think. So we can type in skeletal mesh location, and then it's probably going to give me some stuff, some errors or warnings. Actually, let's skeletal sample skeletal mesh. I think object has warnings. The display object has warnings. Check the object properties or the message log for details. Let's go to the message log. That's also one very handy skill to I think is basically try understanding and reading the errors and warnings, because Niagara wants to help you. And I've been kind of avoiding all the warnings and errors for a long time until I actually started reading them, and I was like, ah, okay, no, that kind of makes sense. So there's a Niagara log as well, and it says check the message log for details, but there's nothing. So I'm just gonna continue on and select our mannequin, and hopefully no, that didn't really do anything. So sample skeletal mesh, and then maybe skeletal mesh location. Oh, that didn't do anything as well.
Yeah, I've been struggling with this part.
Also, what's kind of annoying is that the Niagara developers keep changing these modules. Like this is a different module than the one I was working with. Like the last time I did this, this kind of worked. Sample skeletal mesh, and then use the skeletal mesh location. Don't know why it's not working now. Maybe there's a skeletal mesh location update. Maybe I just do it. Yeah, I'm just kind of fucking around at this point. I'm not sure. I wish I had a more clear answer, basically. I wish it was that easy, but it it used to be that easy, but
Into maybe if you figure it out before next week, Richard, you could
Yeah, I'll try.
it'd be a good homework exercise.
Yeah. Because the plan is to like have a real-time particle system which follows the skeletal mesh around. You know, so like your avatar could like have some particles attached to it, or the particle system could form the mesh, which then it could be deformed or whatever in any way. So I just was looking to play around with that really.
That's totally possible. Actually, one of the first official Niagara tutorials from Epic Games is about exactly this. Niagara. That's also where I got this. It's this one. So building advanced effects in Niagara. It was posted 1 year ago. It's probably deprecated. Like all my tutorials include help text in the description, because most of the modules I used 1 year ago are already deprecated. But yeah, definitely check out this tutorial from Epic Games to
Cool, cool.
render some particles, some skeletal meshes.
Yeah, nice one, man.
Yeah, that one I actually used to make the little intro video as well, so that seemed to work for me like the other day. So it might not have depreciated too much. So yeah, might still be pretty good.
Cool.
Nice. Yeah, it'd be cool to see what you might make with that. That'd be awesome.
Yeah, I'll try to get something for next week.
Nice. Yeah, awesome. Thanks for asking. If
Cool.
anyone else has any questions, do jump in. Or if not, we can say but yeah, we'll catch up more on this next week. Really, like I think a cool way to do this would be, when we have a big learning session like this, to jump in, see what people might have made of it in the week after, and have a bit more of an informal one. Oh, that's just so cool watching you sweep those about.
Yeah. That's the fun part of particles, getting to play with them. For sure. I can actually like yeah, for sure. Yeah, I could build off from this for days again. Yeah. It's also like kind of like a bullet is entering a wall, like, and then it pushes out the particles on that side. Yeah, fun stuff.
Yeah, I'm definitely gonna watch this back and figure that out myself as well. Really, really cool. Yeah, I guess, yeah. Like, obviously, thank you so much for giving your time up to this. It's been super, super helpful. Loads of
Yeah, no
tips.
worries. This was fun.
And
Nice little masterclass.
yeah. Well, yeah.
I actually proposed the title of show and tell, but a masterclass is fine as well.
Yeah, nice. And yeah, as I say, like, to everyone who's listening, just expect more of these. Probably around monthly, hopefully. We'll try and get someone in to talk about. It'll be just total different things every time, really. We've got people that go into more of the sort of changing cameras on button pushes or other virtual production stuff, or other creative stuff. Maybe even people that just use 3D modeling programs like Blender or Houdini or something. So just massive range of people sharing skills, and then in the sort of cool down period between these, we'll just be hanging out same time Wednesday at 5 o'clock, and we'll just sort of share notes and all this stuff, really. So yeah, thanks again, Sam. Super, super amazing. Thanks for kicking this off so nicely, and I hope this inspired lots of people.
Cool, no worries. Nice one. All right, I'm gonna jump off. This was fun. Talk to you later.
Yeah,
Thank
thanks so much.
Bye.
Cheers for the questions as well, Marty.
Yeah, of course.